Let's look at finding an equation given the graph. So we're kind of working backwards from what we've done before. So here in our example, we have a graph over there on the left side. We want to find the equation. And like we noticed in the last lesson, graphing from vertex form was a lot easier than graphing from standard form. So it makes sense to say that it's easier to write the equation in vertex form when we're given a graph. Because we need two specific things. We need, number one, the vertex. And number two, we just need another point. Any other point on the graph will do. As long as it is another point that isn't the vertex, ideally we'll work with a nice point like the y-intercept, but we can choose any point. So in this graph here, we have those two things. We have our vertex. We also have our y-intercept. That's all we need to find the equation. So remember our base vertex form equation was y equals a x minus p squared plus q. Right? Make sure you're not missing that minus in the middle there. And we can solve any equation as long as we get it down to having only one unknown. And so in this case, because we have 4 points here, we can fill in 4 of these 5 blanks. We have, from our vertex, remember the x-coordinate was a p-value, the y-coordinate was a q-value, so we can plug those values in for p and q. So I'm going to go ahead and do that. I'm going to have -1, and I'm going to put -4 outside. All right, I still have the rest of this to fill in. Because we chose another point, and because it's related to this graph, it's on the graph, I can call that an x and a y. And I can substitute those in for x and y in my equation. So x is 0, I'm going to replace the x with 0. Y is -1, so I'm going to replace the y on the left side with -1. And then all we have left is a, right? We have to have a variable somewhere or else we're not solving anything. But I know everything here but a, so as long as I follow proper order of operations, I can isolate a, right? I can get a by itself. I can tell you the value. So let's start to do that. First thing I'm going to do is move this extra term to the other side, right? I'm trying to move things away from a. So I can get rid of this -4 by adding 4. But what I do to one side of the equation, I have to do to the other, so I add 4 to the left side. I'm left with 3 equals a. While I'm here, I can do 0 minus 1. That's just a -1. Remember, these are combined through multiplication. So I have 3 equals a times, and when I do -1 squared, it actually becomes a +1. The last thing I would do, and it's a little silly here, but we'll do it anyway, I would divide both sides by 1 to cancel out that multiplication. But in this case, we just get 3 equal to a. Now that I have my a value, remember a, p, and q are specific characteristics. So I can go ahead and plug those in. So remember our general form was y equals a x minus p squared plus q. If I'm talking about an equation, I want to keep the y and the x as variables, right? Because I want to talk about the whole function. We substituted x and y in before so that we could solve for a, but then that's only referring to that one specific point that we had in green. I want to make sure my equation represents the whole graph. So I plug in my a value. Out front is my coefficient. I'm going to include my p and q values because the vertex is a point that won't change. -4. And then this is my equation, right? We have room for x and y's to describe every point on the graph, but we filled in those specific points, those specific characteristics like a, p, and q. Let's try another one. So again, I have any points on my graph and I have my vertex. So we have our vertex. We can pick any point, right? I could pick my y-intercept down here if I wanted, if it was a nice value. Or I could pick any other nice value, right? By nice value, I mean something that hits a nice intersect, right? I don't want to pick like this point here because I don't know if that's like -0.12, -0.13. I want to make sure it's a nice point that intersects those integer values. I would always start by labeling these things, so make sure you know which one is P and Q, and which one are you calling X and Y, right? And it's important that you don't mix those two things up, right? P and Q has to be the vertex. So I go to my general equation, y equals A, X minus P squared plus Q, and I start to plug in these things. So y is 3. I don't know A because that's what I'm trying to find, right? That's the tricky part. A is not a point on a graph. It's telling us how our graph has been manipulated. Is it up or down? Is it stretched or not, right? So A is not a point. That's why we have to find it in this way. My X value is -2. My P value, on the other hand, is going to be +4, right? Because remember, the sign always flips. If it helps, put minus and then a -4. And then our Q value is a +5. So now that I have everything but A, I can go through the process to solve. Again, first thing, I'm going to move this 5 to the other side. Right now it's being added, so again, I do the opposite operation. I subtract. So I get a -2. Whoops. -2 equals A. Again, here I'm going to do -2 plus 4. I'm going to get a +2. I'm going to square that first. -2 equals, and a couple things you could do. You could write this as A times 4. You can also write it as 4A. We generally write those coefficients out front. Either way, we need to make sure we know it's being divided to pull it away from A, right? We do those opposite operations. If we can, we'll leave this as a fraction, right? 2/4 is 1/2, and it was overall negative. So again, make sure you're not done here. You have one more step. Y equals, you plug in this A value, -1/2. You plug in your P and Q, X plus 4, right? That sign is flipped. Even though P is -4, we always subtract P, plus 5. Make sure you're putting your P's and Q's in, not your X's and Y's, so that it looks like the equations we're used to. And there's our equation in vertex form. So that's where we're done with vertex form. In the next lesson, we'll look at our third and final form. We're going to talk about factored form next.